In this demonstration, we will provide you with a brief introduction to the DataWalk Integrated Data Hub. We will show how disparate data sources can be quickly integrated, how the flexible logical data model can easily be modified, and how the system can easily be queried without SQL or programming. We log into the DataWalk application, where the first thing we need to do is to create a data structure. In this case, as we just want to quickly create and validate a structure and its connections, we will do this with Excel files which provide a very precise description of data types. For this we will use some fictitious banking data, and we can start with a small Excel file for a set of accounts. We can see that this file contains various columns such as the account number, name on the account, and so forth. For creating the structure, we will use skeletal data sets with just a couple records. In this case we have system administrator privileges, which gives us the capability to structure the model. We simply drag the Excel file into DataWalk's Universe Viewer, which provides a simple visual interface for all the data in the system. The system will automatically detect the columns and their formats, and will create a data set into which additional data can automatically be ingested. This process of setting up the structure takes a few seconds for each set. We take a quick look at this data set in DataWalk, and we see the same column names and data as we previously saw in Excel. We continue to build out our data structure by adding a small data set of customers and another small data set for transactions. A key capability of DataWalk is to identify and analyze connections within the data, so now we will specify the connections of interest. To demonstrate this, we will use DataWalk's private connections. We'd like to associate customers with the accounts they own, so we simply drag a new connection between these data sets and specify that we want to generate a connection called owner that connects account holders from the customer data set to account names in the accounts data set. We should note here that private connections are available only for a specific user, but once such connections are validated, they can then be shared across all users in the system. We would next like to connect accounts and their associated transactions, so we first connect incoming transactions by connecting account numbers from the accounts data set to beneficiaries in the transactions data set. And for outgoing transactions, we then connect account numbers to remitters in the transaction data set. So in just a few minutes, we've now built a logical model of our data, including both data sets and connections. The system is now ready to ingest and analyze any data that fits into this model. Each time a data set is imported into DataWalk, the system automatically creates specialized folders where we can drop CSV files in order to add more data to that set. For example, at the moment we have a small number of records in our transactions data set, and we have a CSV file with additional records that we would like to add. To do this, we simply drop this CSV file into the drop folder. Alternatively, Flume, Kafka, or any ETL tool could be used to automate this process. We now see the size of our transactions data set has increased with the new records, reflecting that data from the CSV drop folders has been added and that this data is ready for analysis. In practice, at this point many customers will add additional data to the model and then start doing real work, as the system is fully usable and the model can be extended over time without interrupting operation. With this, we've shown how a data structure can be quickly developed using only business objects without any physical model and without any technical expertise. We will now fast forward to a more developed version of this model. Specifically, we have used the same processes as before to extend our model with additional data, data sets, and connections. We've also changed the connections to public connections that are visible to all users of the system. All of this took us a few minutes. We just didn't want to take you through all that in this short demo video. The datasets we've added include an alerts dataset, which refers to automated alerts that may have been generated for suspicious banking transactions, and various other banking-related datasets. DataWalk has a flexible logical data model that enables you to easily reconfigure or change datasets and connections. For example, we may decide that we'd like to have different connections for personal accounts and business accounts. To do this, we will change the owner connection to owner personal and connect owner with account holder. And for business accounts, we will introduce an additional connection that will connect owner with company name. We'll also note here that connections can be much more sophisticated than just a simple match. We can see that DataWalk's logical data model enables you to easily create and modify your data structure. without SQL queries, and without programming. Unlike other systems that require you to agonize about defining a rigid physical model, with DataWalk you can quickly implement a first pass and then iterate on the model to modify the data structure as your needs change. So a project that may take many months to implement with other systems can be done in days or weeks with DataWalk. Next, we will demonstrate how to query the data. Here on the Universe Viewer, DataWalk provides the ability to do advanced filtering. For example, let's say we want to find all accounts that did more than 2 transactions over 100K. We set accounts as our perspective, set a filter on connected transactions to those over 100K, and now we filter on the connection to only present those with more than 2 such transactions, and we see how many accounts meet these criteria. Now let's see how you can iterate through the filtering. We want to see how many of these transactions alerted. Now we can click on Transactions to see which of the previously filtered transactions are those that alerted. Now we can go further and see which accounts were affected. So what we have found are the accounts that did at least 2 transfers of 100K or more, which invoked alerts. And of course we can easily view the resulting accounts, and if desired these can easily be exported to Excel. With other systems, getting these results would require generation of time-consuming SQL queries by SQL experts. But as we can see, with DataWalk there is no need to generate SQL queries. Instead, both analysts and business users can query the system simply by traversing and filtering through this simple visual interface. If you want to modify your query, you can simply pick up where you left off and refine your query. For example, we may decide that we only want the top 10% of large transactions, so we simply add an additional filter. With alternative systems, this would typically require generating a whole new SQL query or doing additional programming, but with DataWalk it's a simple, instant iteration on a previous query. We can save this analysis, and with this we've essentially created a data mart. Next, in part 2 of this introductory video, we will show you how users can also search the system for specific data, analyze data via instant OLAP, analyze flows around a network, and do analysis via network graph, all without data movement, and can use DataWalk to subset data for further analysis in R or other tools.